Alright, so welcome back to your flip videos after your long, probably much needed break. So here's our first one for this semester about the ocean floor. I know we have looked at Finding Nemo for the past couple of days about some different ocean floor features, but before the 1900s, scientists thought that the ocean floor was completely flat, which of course we know is not true. So hopefully you don't think that, especially after watching Finding Nemo, and maybe that wasn't your first time watching Finding Nemo, but hopefully you know that it's not flat. So how do we know that it's not flat? Of course there are places on the ocean floor that we haven't been able to reach yet, but we use this thing called sonar, which is just kind of like sound waves, kind of like how we do for finding out the different layers of the earth and what their composition is and what phase of matter that they're in, if they're solid or liquid, and how they bounce off and things like that. But there is a specific formula to find the depth of the ocean. Depth equals V times T, and that's time, and the volume, I believe, or I'm sorry, the velocity. And you only want half the time, because if you think about it, the time that it takes to get back to the boat would be from the boat all the way down and back up. So you only want half that time, because that half of that is going to tell you the depth from the boat to the ocean floor. You don't want the distance from the boat to the ocean floor back up to the boat, because then it would be double. So on your piece of paper, you have a sample problem, so make sure that you solve that and you have an answer for me tomorrow on your sheet of paper. And the velocity of ocean water is about 1,500 meters per second. So you will always plug in that that number into your velocity for your formula. Hello, I couldn't think of the word. So make sure you plug that in when you're solving that sample problem. Water pressure, we're going to talk about that a little bit later, how it increases with depth. So the deeper you get down, the more your ears are going to pop, and that is due to the water pressure when you get deeper. So this is kind of the continental margin altogether. This includes the continental shelf. So if you want to think about it like a bookshelf, it's something that's risen up and it's kind of flat. The slope is actually, well, a slope, and then the rise is when it starts to level out again. Here are a couple different things that we're going to talk about. We're not going to talk about all of them, so don't worry about all of these things. There's going to be a better picture later on if you want to make a sketch about all those different things a little bit later on the right side of your notes. The abyssal plain is pretty easy to remember. This is the flat part of the ocean floor. You can remember that by the actual word plain. If you think about maybe the Great Plains or a plain, I don't know, in the US or something like that, that is the flat part of our Earth's surface. So plain just means flat. Mid-ocean ridge we talked about quite a lot with plate tectonics. We know that this is a divergent boundary. This is where seafloor spreading happens, and we know that the new crust, or we talked about it being a jelly donut, all that new jelly is right near the hole, and then it kind of comes out here, and this is where the older crust is, and it kind of makes kind of mountain-looking things. So this is the Mid-Atlantic Ridge. This is the most well-known Atlantic or mid-ocean ridge that we know about in our world, and this, if you look about the shape of the Mid-Atlantic Ridge, it actually kind of looks like the border of Africa and also the border of South America, which is kind of cool. A seamount is next. These are underwater volcanoes. Sometimes they reach the surface and they can be, form islands just like Iceland, so that's kind of cool to know. They're called guyouts if it has a flat top, which is due to erosion. So a seamount will always be a seamount first and then transition into a guyout based on, the weathering and things like that. This is a picture of Iceland. It's actually at the top of the Mid-Atlantic Ridge, which that, that's not a coincidence. It formed because of the Mid-Atlantic Ridge and having volcanoes and things like that. The next thing is a trench. We've talked about this too. This is at a convergent boundary. This is when it comes together. It forms kind of like the top of a heart. Your example is the Mariana Trench, sorry. And it's the deepest known place on Earth. It's about 11,000 meters, which is about 36,000 feet deep. They actually reference this in Finding Nemo. We talked about that a little bit. So make sure you have that down as well. Let's see. Hopefully this will work.
Loading.
Oh, and it's speaking to us.
Loading done. Features of the ocean floor. Uncover the features.
All right, so you can look at this at your own time. I'll put this link up on the blog, and she's really annoying me, so we're not going to listen to her. Okay, so here is the picture that I wanted you to look at. This is exactly what your Play-Doh model is going to look like later on this week. You will need to know where each one of these are and what they look like. Again, this is the shelf. This is the flat part. This is usually where the beach is. You know, you can swim right here and things like that. But if you go deeper and deeper out, you'll come to the continental slope. And then right up here is where the rise is. I know it's not labeled right here, but that's when it starts to level out into the abyssal plain. Seamounts are the ones that are underneath water, but as soon as they reach the surface, it'll become an island or a volcanic island. The mid-ocean ridge is a convergent boundary. A divergent boundary, and it kind of looks like the mountains like that. And the trench is actually a convergent boundary, and of course that's one of the deepest parts in the world. And then of course you have your continental shelf on the other side whenever you get to the other side of whatever ocean that you're looking at. So this is what you're going to be doing later on this week. You'll have to build all 6 of those things. And here are some questions for you. If you were able to walk along the ocean bottom from a beach, which feature would you reach after the continental shelf? That would be the continental slope. The area underwater that is closest to the shoreline is the continental shelf, continental slope, mid-ocean ridge, or we haven't even talked about that, so it would be the continental shelf. The blank is a broad, flat part of the deep ocean basin. That would be the abyssal plain. At what point in the diagram above would hot magma most likely rise through the ocean floor to eventually form a volcanic island? That would be point B. That's a mid-ocean ridge right there, not the trench. This is a trench right here. No magma is going to come up from there. This is where the magma would come up because you can kind of see where the mantle is kind of coming up a little bit anyway. What is most like a mountain range? We know that's the mid-ocean ridge. A seamount is a single underwater mountain, so don't get confused with that. A mid-ocean ridge is a mountain range. So hopefully you got all your notes and you bring them in tomorrow so that way we can take our quiz later on this week and also make that 3D model. So good luck. Hopefully you got everything.